Good morning, afternoon, and evening to all of you from wherever you are joining us today. Please feel free to scan the QR code and do the event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access links from today's session. I will share the event check-in link and the QR code again with the event ID in the Q&A section shortly. Thank you all again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on a code of conduct. We display this at all Microsoft Reactor events that we run and is just a reminder to be aware of others. The key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Dikshit, our speaker for today's session. Dikshit started his journey with Microsoft in 2015 as a part of IIS team and later moved to Azure. During his cloud journey, he has worked in various past technologies like Azure App Services and Azure Functions and many more. Currently, he's a part of Fast Track team helping startup in their cloud journey. But for now, I will hand over to Dikshit to start the session. Over to you.
Thanks, Rashmita. Thank you so much. Good morning, good evening, and good afternoon. As Rashmita has already introduced, so I give my I can say a brief, a little intro. As of now, I'm working as a customer engineer in the fast track engineering team, and we are helping startups in the cloud journey, in their journey from from the we can say from the starting point till the production baseline. So that is how we are helping startup across the pan India. So just the couple of things. So today's sessions we are going to fundamentals. We are going to cover the fundamentals of Kubernetes on Azure, and we are going to have the recurring session that is on 26th of August, in which we are going to cover the we are going deep into it, and the intention is that in the subsequent
Diksha,
session. Yes, Vivek. Hey, Vivek.
You can continue, Dikshit.
Okay, got it. So in the subsequent sessions, we are going deep and defining the production baseline. So today's sessions will be setting up the, you can say, the baseline and the fundamental of Kubernetes, so that everybody probably who's starting their journey on Azure or who is starting their journey on Kubernetes will able to understand that what is the fundamental concepts of Kubernetes and why we are using it, and what is the basic infrastructure of Kubernetes and Azure. So it's just about setting the fundamentals so that we can go deep dive into the subsequent sessions. So let me share my screen.
Just to interrupt, Dikshit, before we start, I'm requesting all of you, please kindly mute your mic.
Okay, let me share my screen, guys. Uh, I believe you guys are able to see my screen, Rashmita.
Yes, Dikshit.
Got it. Thank you. So the today's topic will be the fundamental of Kubernetes and Microsoft Azure. So first of all, before moving on to the Kubernetes, that what is Kubernetes and how it is being laid down at the Microsoft Azure, and what are the benefits of this. I just wanted to have the a little one step back and discuss about what is container, and what is the problem containers are solving at present, and how does Kubernetes will help us, all of us, in coming into the picture and having those things which might be overwhelming while having their application or having running the application at the container levels. So first of all, if we talked about that, let's say at present, or if we talked about any business scenario where there is a sudden surge in particular request, for example, um, let's say we are running our application, and as of now, the application, the workload that the application is taking about is 1 million, and by let's say you are running certain sales, or you are having certain business scenarios, or due to certain conditions there is a sudden surge, and from 1 million it suddenly it drastically goes to 1 million to 10 million, or let's say 5 million. So what is the best use case of handling such scenarios, or what is the best use case of running those applications in any cloud environment, or particularly in Azure? Either the options would be, either we can go for the VMs, or either we can go for the Azure container, the containerization of the applications, and or we can choose the other options that we are going to discuss. But let's say if this particular scenario, when we see the surge from 1 lakh to 5 lakh, or from 1 lakh to 10 lakh, the first option would be that if you're running your infrastructure, or if you're running your application on the you can say on the VMs, then obviously it would take time, because spawning up the couple of VMs at the backend, which eventually will take time. And also, this can be particularly quite easily handled if we are running our application on the container instances. Yes, so container instances can handle the scenario, but eventually at the developer level, or the at the you can say the admin level, but still there will be a lot of the work that needs to be taken care, that handling the containers infra, uh, how to load balance of traffic, maintaining the CI/CD pipeline, what is the health prob if the containers are dying, or what is the health when the application is running, if there is certain you can say if there are certain spikes in the memory, if there are certain spikes in the CPU. So all those things we need to be also taken care at the container level also. So going further, so these are the couple of things that even we are doing at the container management, or even let's say when we are doing at the you can say running your application at the VM. So we need to handle those scenarios. So one is the cluster management, how's the container is running, the scheduling thing comes into that particular thing, the load balancing part, and even the logging part. Let's say as we discussed, that there is some spike in the CPU, there is some spike in the memory, but yes, we need to evaluate that what is going on at those. So what is the centralized solution, or what is the you can say the best solution that we can come across, that if you want to handle a certain surge uh, uh, um, at the application level, or at the product or the service level that you have developed, so that it can handle everything. And even you don't want to manage and even the maintenance part, with respect to the scheduling, with respect to the health check, with respect to the logging and monitoring, anything from the CI/CD perspective. So everything will be taken care by the one thing, which can which can manage everything. So for that particular thing, the Kubernetes come into picture. So it is basically, you can say, the orchestrator which will help us in managing all the things that we have just discussed. For example, the cluster management, the life cycle, the health checks, the CI/CD pipeline, even the scaling thing, uh, how to discover that particular service running in a cluster. So all those things will be taken care, and will be provided by you, by the Microsoft Azure in the Kubernetes form. So moving forward, when we say Kubernetes, so as of now, when we work with many customers, whether it is at the startup level, whether it is at the enterprise level, it is becoming the de facto, you can say, the de facto standard of of uh, of the application, or the application, the containerized applications. So the benefit of the customers, why they are running, why they are choosing the Kubernetes. Uh, well, as of now, it is quite even the Kubernetes started their journey probably 4 years or 5 years back, if I'm not wrong. That is close to 2015, I believe. And it is quite modern and pluggable, and you can quite you can it is an open source project, and you can also have your custom pluggable things. If you want to develop on the top of it, you can do it. And you can run it anywhere. whether it is in the public cloud, whether it is in the private cloud, or even in the edge devices. We will going to discuss in the upcoming slides. And also the if something goes wrong, whether from the node perspective or whether from the you can say pod perspective, so it has the ability to auto heal that particular thing. So that is why it is becoming the de facto of uh, uh, the de facto of across the industry of having the leading orchestrator part while maintaining the containerized application. So key features, as we discussed, that the let's say you're running your application in a in the Kubernetes cluster, and something happens at the pod level. So we will uh, discuss all those things. Uh, so something happens at the pod level, pod dies, or let's say something happens at the node level. So all those things, the self healing part will be taken care by the Kubernetes. The auto scaling part, the search part that we have discussed. Let's say if you are if your application is running and there is a certain surge, how do you want how do you want to best tackle that particular scenario when you're running when you're choosing the container orchestrator, the Kubernetes, the service delivery and the load balancing, the storage thing, the pods, and if you want to store some of the secrets or any sensitive information related to the applications, you can very well have it in the Kubernetes. So before going on, so just wanted to have the basic things that we keep on. There is a general term called pods. You can say containers or Docker. So what are all they, and what is the difference between them, so that we can at least everybody can be at this some basic level, even who is starting their journey in the Kubernetes. So we can say when we talked about let's say just I'm taking one step back, and when we talked about the virtualization in the case of Hyper-V, so in those particular thing, the developers or the admins, we are actually virtualizing the hardware part. So it assumes that every application has got its own hardware part. But when we talked about the containerization, it's uh, we can think it of it that it is basically virtualizing it's the OS part and the application running in that particular thing, the application running under that particular hood. Assume that the OS belongs to that particular application, and there is no other application who is utilizing and running that particular OS. So we can say the virtualization will think, if we talked about the virtualization, it's about the hardware, and when we talk about the containerization, it is at the OS level. Now, what does container do, and what is container and what is pod? If we in the Docker world, the smallest unit is called the container, and in the Kubernetes world, it is called the pod. Now, containers always runs inside the pods. Okay, so basically, what containers do, they run your applications. So application will run under the containers. There can be a single or multiple containers that will run under the pods. And if we thought about the you can say uh, the from the
Dikshit,
Kubernetes.
sorry to interrupt. I have one question. So, what will be means Dockers and Kubernetes? What will be the basic difference?
So Docker is the so thanks for asking this question. So Docker is basically the container runtime engine. So let's say you have an application and we want to containerize that particular application. Now when we talked about how we can containerize that particular application, so there should be a container runtime engine. So the container runtime is called the Docker, and the you will containerize your application by making the by creating the Docker file, and out of the Docker file we will create the image, and out of the image, when the image is there, we will create the container, and under that runtime, which is the called Docker, it will eventually help us to run your application on which you want to run it. I hope I'm making my point clear. If there is any questions, please let me know.
Okay, so actually, I'm little new to this Docker and Kubernetes. So, means like a Docker's means it. Previously, we use virtual machines, right? So,
Hmm, hmm.
to replace that concept, Dockers and Kubernetes games like to run this infrastructure smoothly. What I'm understanding, correct me if I'm wrong. So,
Just
actually,
just
correct.
little addition I can say. Let's say if we take about to understand it in a very layman term, uh, so that who is new to this world, let's say uh, you want to run your application, or as of now you are running your application on a VM. Let's say you have a e-commerce application which is handling some request, let's say 1 million. Now in a sales day, there will be a sudden surge, let's say from 1 million to 10 million. Now from your perspective, the developer or the admin perspective, the one thing they can do, they can scale out those VMs, add more number of VMs. Let's say if you are running on one, to cattle that particular surge, they can increase the number of VMs on which application is running, right? Now when we are increasing the number of VMs, eventually at the backend, it will take some time. If that particular search is you can say is quite certain, let's say as of now it's running on a 1 million, and at the another second it is running on a the search is goes to 10 million. Now if we want to scale out, or if we want to increase the number of VMs on which application is running, eventually it will take some time, but during that particular time, all the user who are accessing that particular application will get some unweird errors. But if we take the same scenario in terms of Kubernetes, or let's say in terms of containerization, the containers can spawn up probably in less than 1 second, or probably at one, let's say 2 seconds at max. I'm 2 seconds will be the, I can say, will be the larger term, but yes, it is just the matter of seconds that they can spawn up. So even if there is a surge from 1 million to the couple of to the couple of million to the couple of millions, the scale out factor, or the number of increasing the containers or the pods, will be done in a quite couple of seconds, rather than in the case of VM it will take minutes. So that is one concept. The other part that we are discussing, that in the case of virtualization, we are virtualizing the hardware. So the application thinks that it belongs to this particular hardware. Or probably let me take one step back. uh, let's say I have a couple of environments, dev, QA, and staging, as we generally have in the software practice. So in every environment, let's say you are developing some application and they have certain dependencies. Let's say ABC, they have a certain dependency. Now for you, as a developer, or as a dev admin, you need to be quite aware that when you are releasing your code into the dev, QA, or the staging environment, you have those dependencies uh, deployed when you're deploying the code, so that it work without any issues. So you are deliberately making sure that all those dependencies which are required by the application are, either way you are installing, or they are present by one way or the other. But in the case of containerization, we are making the package of those, so that everything which is required by the application in terms of dependency, or in terms of OS, they are packaged by the image, and it will eventually reduce the dependency on the hardware. So it will not be it will not be the case that if something is working in the dev environment, it should be sure that it would be working in the case of QA and the staging environment, because nothing is changing, because we have created a package, and out of that particular package we have created the image. So the image will be the same for all the environments. So it can't be a case that something is working in one environment, but that particular thing is not working in the other environment. I hope you will at least now will get some pictorial representation of.
Thank you, Dikshit. Thanks for clarifying.
Sure. Thank you. So moving on. So how is the Kubernetes there on the Microsoft Azure, and what is there? So basically, this is the high level, you can say, the infrastructure that the Kubernetes cluster has. so it has the master nodes and it has the worker nodes. So master nodes, basically it is the heart of the you can say the Kubernetes clusters, and under the master nodes we have the API server, the controller manager, and the scheduler, and the some DB, the etcd, that part. So the API server, what is the functionality of the API server is it basically takes the you can say the request from the system admins, and when we are managing the cluster, the request goes to this particular API server, and this API server forwards the request to the other components. So basically it is the core thing. So whenever the admins will the admin will make a request by the let's say I want to deploy that particular application by the YAML file. So whatever request I'm making, so that particular request will go to the API server, and depending upon the API server will route that particular further request to the other services. Now, if we go little deep into it regarding the controller manager, so we have the Kube controller manager, which run 4 services, um, which is called the node controller, the replication controller, the service account, and the endpoint controller. So just to have it a little brief over it, so that you will get the you can say the brief idea that what is going under the hood. The node controller is responsible that all the nodes present in the cluster are highly available, and it keeps the track of the status of the nodes. For example, on the right hand side in this particular pictorial, we have 2 nodes: worker node 1 and the worker node 2. So worker nodes basically mean you can say the VM scale set, or the VM. The VMs, we call it as a node, the worker node 1 and the worker node 2, on which our applications are really running. So the master node is for managing the Kubernetes clusters, and for managing the worker nodes and the communication between the various components that we are going to discuss just now. The worker nodes are the actual nodes on which your application is running. And when we talked about the other services regarding the application controller under the Kube controller manager, it is responsible for maintaining the desired state of the pod. And the other services, endpoint controller and the service account, well, for example, endpoint, as the name suggests, it generates the endpoint for service, and the service account and the service account controller is responsible for the authentication and the token creations. So in a nutshell, probably just to understand if I want to give a summary of the API server and the control manager, the API server will take the request, and depending upon what is the request, it will further request to the other components in the Kubernetes cluster. The controller manager, under it we have the couple of services, as we mentioned in the diagram. Its basic function is to keep track of the nodes, how nodes are working, are they healthy or not. If you are running your application, it will create the endpoint for it, so that it can be accessible, and it makes sure that what is the desired state of the pods that is running. Now there is one more, as we have the controller manager, there is one more, you can say, the cloud control manager. I have not shown it, just to give you the brief over it. There is one more cloud control manager, which will make sure that whatever communication we are making from the master node to the worker node, when we are interacting with the Azure platform, for that particular functionality they are responsible. But that is under the hood. Just giving you the brief that there is one more component apart from the controller manager. And one thing, the other the let's say we have a pods, and so the pods are stateless. So if the pod goes down, we can't revive the pod, and we need to create the new ones. So that functionality will be taken care by the Kubernetes cluster itself. But yes, if as a customer we want to have the data consistent to that particular, you can say, to the pod, and we want to retrieve that, we need to attach the volume or the disk to that particular pods. For the configuration side, that what all configuration we are running in the Kubernetes cluster, that for that particular thing, we have the database. which will make sure that it has all the information of the cluster. And on the other thing is kube scheduler, which is responsible for scheduling the pod on the node. And on the right hand side, we have a kubelet and a kube proxy, which is responsible for extracting the network rules on the host, and it will forward the communication. So in a nutshell, uh, as a developer or as an admin, when we talking about the Kubernetes parts and the master node and the worker nodes, you will only be managing the worker node part. The master node part will be taken care. Everything will be taken care from the infrastructure perspective, and everything from the health probe, making the communication, creating the endpoint. Everything will be taken care by the Microsoft Kubernetes, by the Azure platform. So as a developer or as a admin, you are only maintaining the worker node. And even when you're creating the Kubernetes in the Azure portal, in the resource group and in the subscription, you will only be able to see the worker nodes, the VM skill set, the agent nodes, we can call it. But the master nodes will be extracted from you. So that is also the, you can say, the basic or the fundamental difference between the you can say the Azure Container Services that we have. In the Azure Container Services, even the master node, you will have the complete control into the master node, and you can SSH into the master node as well. But when we talked about the Kubernetes, it's only the worker node that will be given to you, and we are not charging for the master node as well. And Microsoft is taking care part of the Azure platform is taking care of the master node. And also one more, just to have it uh, the thing that a pod can be run only on one. When we say a pod cannot be span across multiple nodes. So for example, if a pod is running on a worker node 1, then it can die, restart, or keep working on node 1. It can't be a case that pod 1 is also running on a worker node 1, and it can also running on a worker node 2. So wherever the pod exists, it will die, and it is the responsibility of the Kubernetes cluster to restart it again. Any questions for this fundamental architecture? Because uh, once this is clear, I believe the subsequent thing or how the Kubernetes works will be quite easy for us.
Yeah, Dikshit, I have one question. Um, as you said, VMs will be auto scaling based on the traffic, right? So, if anything, you have in lot of in n number of containers, you are maintaining images. But if any update is required for a particular container, so for that, how we can?
So there is a so first of all, there is a concept called node pools that we are going to discuss in the upcoming slides. For example, let's say
Okay.
you want to keep uh, let's say in this particular pictorial thing, there is worker node 1 and worker node 2. So there is also a configuration or the practice that you can keep the different configuration of the VM skill set uh, under the worker node 1, by creating by the node pools, and keeping the other configuration in the another node pool. So let's say under the node pool 1, I have a configuration of the VM skill set which is having a configuration of ABC. When we say ABC, let's say 8 GB of RAM and certain cores. And in the another node pool, I can have a different configuration of the VM scale set, which might be on a let's say 16 GB or certain GB of the other configuration still. So by separating those agent by creating those you can say the agent pools, uh, you will be able to have those independent configuration styles for that. So moving on to the
Dixit, sorry, hi, this is Arnab. I had one question to your previous slide. So, could you explain why is that internet layer interacting with the worker nodes directly as opposed to going via the API layer? It's not clear how routing happens across the worker nodes if the workers are directly exposed to the internet IPs.
No, it is just the pictorial representation, but yes, by exposing you can say the worker nodes, we need to put the load balancer or the application gateway, basically the ingress controller. If either you can put the application gateway, either or you can put the Nginx. So it all totally depends upon the customer that whatever control that you are looking for. For example, if I go by the layer 4 load balancer, there are certain things which I'm not able to do. For example, the SSL termination or or the routing based on uh, uh, the URL routing. For example, there is you can say at the application I have a facebook.com and I want to go at /Dikshit. So those application request routing can't be handled at the layer 4 load balancer. But when we go at the layer 7 load balancer, things like SSL termination, the application request routing, all those things can be taken care. So it is just the pictorial thing, but yes, you need to take. We need to have the load balancer. Either at that totally depends upon you. Either you go for the you can say the layer 4 or the layer 7 or the other the load balancers that we have.
Okay, thank you.
Dikshit, one more question. Yeah. Actually, if to refer your, I mean, pictorial thing here. So Docker will do like it will contain inside Docker a number of pods will be there and containers will be there, right? So the main difference between this Dockers and Kubernetes is Kubernetes will give extra functionality like I mean communicating with other outside world to you to your containers and Azure accessibility. All these things it will Kubernetes will do. Is that the difference?
Uh, no, I will not say it in this particular way. I will say so. When you talked about the Kubernetes, when you talked about accessibility to the outside world, so those things can be given by other services also. Let's say you are running your application on the VM, or you are running your application on the app services, or let's say any if you are aware of the VM scale set, the app services, the function app. So you can expose your application to the as a public endpoint, and they will be able to access it. So it is not the idea that only Kubernetes will provide the outside access of your application. No, it is just that when we talked about the scenario of, let's say, a sudden surge from 1 million to 5 million or to 10 million. So if we if you want to increase the number of VMs on which application is running, it will take a larger time. Or probably let me take the example of, let's say, in India we do have the e-commerce sites, Flipkart, Myntra, all that stuff. Now let's say on a certain sales day, uh, there is an application surge. So by chance, let's suppose if those applications are running on the VM, not on the container things, or they are not containerized, if they are running on the VM, and if they want to scale out, or if they want to increase the number of VMs, that will take a larger amount of time to increase the number of VMs so that they can handle that particular surge of users. But in the case of you can say containerized applications, the containers will spin up and scale out, or in other terms, you can increase the number of containers to any numbers in a couple of seconds. So it is not that. And also the difference between you can say uh, so container is the part where your application is running. uh, Under the pod can have one container or multiple containers, but eventually, for running your application under the container, there should be some runtime. So that runtime is the Docker engine, is the Docker. I hope if that clarifies the question.
Thank you.
Got it.
So minimum one container and maximum n number of containers in a particular pod.
Yes.
Dikshit, there are some questions in the chat as well.
I'm sorry. Okay, that we have taken the first one. Sarvanan, you mean skill set? Sarvanan, I'm saying the VM skill set. If you mean the VM skill set, yes, then it is the VM skill set. Do the master node and the worker nodes be placed under the same subscription? Can they be a separate? Could I develop my own scheduler for the master? So that is what Chris. That is what I'm saying. So let's say for this particular pictorial representations, we do have the so this is the so this is the Kubernetes. In this Kubernetes master node, or let me go to the another one slide. I will probably I will have those answer. So let's say this particular thing. So the master node is we have the API server, the scheduler, the controller manager, and the other cloud controller.
Hi,
So
sorry to disturb. I can't see any slides. I haven't been able to see them since the start of the session.
So sorry for that. As our other are experiencing the same.
I can see it.
We can see it.
See that. We all fine. I think he need to rejoin. Then
Yeah, I'll try that. Thanks.
We're fine. We are able to see it.
Got it. So the question is that can we have the can I manage the master control?
I mean, master node will be managed by Microsoft, right? As you said.
Yes, that the question in the chat is that can we manage the master node, and is the master node and the worker node will be available in the same subscription? So the answer is that in the case of Kubernetes, that is the advantage of the Kubernetes, that as a Microsoft Azure platform, we are managing the master node on your behalf. So whatever the scheduler, the API server, the controller manager functionalities are will be taken care by the Azure platform. So that is the key advantage of using Kubernetes. But yes, that is why we are saying the Azure managed control plane. The Azure managed control plane, because on your behalf we are managing the master node. But yes, if you want that everything you will need to take care, even the master node, then there is a service called Azure Container Service. In those in the Azure Container Service, you also need to manage the master node as well. So you can log in by, or you can to be specifically, you can SSH to the master node, everything. So everything you need to take care, whether it is you can say security updates, patching, the health prop. So as a customer or as a dev admin, you need to take care that either you want to reduce your work and probably put your efforts in developing the application, or rather maintaining the or managing the infrastructure. But yes, the answer is yes. If you want to manage the master node, you can go for the Azure Container Service. And the other answer is, in the case of Kubernetes, the master control is deployed, but you will not be able to see that under your subscription, because it is managed by the Microsoft under the hood. So as a customer, you will not be able to see the master node under your subscription or under your resource group.
So how many applications can be run in one pod?
So it all depends on how many containers you are running on. But yes, eventually, if you have let's say when we are running the pod, eventually it is running on the VM scale set on the or on the VM. So we need to be you can say quite observant or cautious that when we are running our application, it does not let's say going into the high memory or the high CPU, or probably uh, uh, eating up the resources of the underlying instance. So whatever application or whatever pods or whatever number of you can say containers you are running, please make sure that it is well under the resource utilization of the underlying VM. When it starts reaching, let's say 75% or beyond 70%, then probably you will start experiencing some issues, because we are eventually slowing the underlying OS when there is a CPU or the memory percentage reaching beyond the certain limits.
Okay.
So going further, we have the as we discussed in the previous slides, we have the master components, we have the node components. Master components, we have discussed that what are the basic functionalities or the responsibilities of the components available under the master node, and under the worker node as well. What are the responsibility of the various components that is available in the worker nodes. Moving on, so as we discussed that about the Azure managed control plane. So the other functionality that I will try to describe here is okay, that is done. We discuss also about what is a pod. Okay, so let's say so basically we will go through the deep dive and the other stuff in the subsequent session, just to have the you can say the if you want to, if you're running in the Kubernetes cluster and you want to see that how many pods are running, what is the stage that we have. So these are the certain kubectl commands that we can fire, and we will have the required outcome for that. So the other service types that we have while making the Kubernetes cluster is the cluster IP, node port, and the load balancer. So in the case of cluster IP, so basically so whatever services while creating the Kubernetes cluster, if you want to, if you have a requirement that you want to run under that particular virtual network, because the Kubernetes clusters work because the Kubernetes clusters will get formed under a VNet, under one virtual network. So if the requirement is that your application will only have your application will have the access only under that virtual network, you can go for the cluster IP formation while creating the Kubernetes cluster. And node port, so uh, basically exposing the service, whatever application you are you want to expose on each node, you will be able to access that particular application running on a node, to be precisely on a worker node, by specifying the node IP and the node port. And in the case of load balancer, uh, as we discussed, that when you want to expose the services globally, either by the layer 4 load balancer or either by the layer 7 load balancer, that you can go for the load balancer. Now,
So difference between the load balancer and cluster IP?
so cluster IPs, I hope you will be aware of the virtual network. So when we so Kubernetes cluster is formed in a virtual network. When we say virtual network, it is the private network under which your Kubernetes cluster is formed. Now, if you have the requirement that your application will not be accessible by outside outside your private network, you will go for the cluster IP. But if you have the requirement that if that your application will have access to the outside world by the load balancer techniques that we discussed, you will go by the load balancer.
So both will give external access, like to your application. I mean, beyond your limitation, like that.
So the cluster IP will not give the outside access. Okay. It basically it's saying that it is only reachable within the cluster.
Okay.
Within the Kubernetes cluster, not outside. So I will not go in detail for the networking in Kubernetes, because networking in Kubernetes itself is a, you can say, 1 to 2 hour of a kind of a session. But just giving you the overall picture that so so the networking option is in the Kubernetes, you can go either by the kubenet or by the Azure CNI. So when you go by the kubenet option, I will say the IPs which will be taken by the pods, or okay, let me go one step back. So in the case of kubenet, the IPs which will be taken care by the worker nodes, it will be taken from the IP range of the virtual network, and the IP of the pods will be different from the IP range of the virtual network in which a Kubernetes cluster is formed. It will be a little overwhelming, but please tell me if you are having any issues. So I'm saying in the case of KubeNet, the worker nodes on which our application is running, they will be taking their IP from the VNet range that we have created while forming a cluster. And the pods running under that particular nodes will be taken a different IP range, logically different IP range from the VNet range. But when we are going for the Azure CNI, the nodes, the node IP and the pod IP will be taken from the IP range of the VNet range that we have specified while creating a cluster. So in a nutshell, just to understand it in a very layman term, by default, when we are creating a Kubernetes cluster, it will take the KubeNet. But if you want more control or if you want more advanced features, you can go for the Azure CNI. And within these two, there is an option that, or you can say, or you can have the control that uh, how the communication can be controlled while communicating from pod to pod, or the communication from pod to service communication, or from external to internal communication. Now, to understand it better, uh, let's say I have a three-tier application: front end, middle, and the DB side, or the backend. Front, middle, and the backend. Now, my requirement is that uh, the backend will not be the backend will only be accessible by the middle layer. The front end part or the front app will not be able to access the backend directly. They has to follow this particular process that front app will only have the access to the middle app, and middle app will only have the access to the DB part. So we can have those, we can deploy these into the different pods, into the different containers, and we can define the NSG rules accordingly. It will have those communications inbuilt while taking the you can say the ingress flow. Moving on. Now let's say we are running our application on the containers, and obviously when we say when we are running our application on a container, uh, eventually it is under the pods. Now, as we discussed earlier, the pods, it's stateless. Now let's say when due to certain situation a pod, there is an error in the pod, or pod dies, so eventually your application state will not be preserved. Now if you want to preserve that particular state of a pod, as a developer or as an admin, we need to have the persistent storage, which can be mounted to at that particular pods. So that is the fundamental concept of volumes, that if you want to have the storage persistence which is associated with a particular pod, you need to have you need to attach the volumes. So the couple of supported volume types, and we can have it, for example, the Azure file volume, the Azure disk, and the other we have it the various volume types that we have supported in the case of Kubernetes clusters. Moving on, the AKS virtual nodes. Now, if we remember our first slide, we have the master nodes, we have the worker nodes or the agent nodes. And as a dev, as a developer or as an admin, we are in the Kubernetes in the Kubernetes world, we are not managing the master node. That will be taken care by the Microsoft Azure platform, but uh, uh, we have the complete control over the agent nodes or the worker nodes. To go beyond one step further, uh, let's say, well, this will show the pictorial thing. So as of now, there is nothing. We have discussed all those things in the previous slides. So we have the you can say uh, the admin or the developer by the YAML files spawning something, and it will go to the master node, and master node will pass on the request to the worker nodes. Or in this case, I've written the customer VMs just to pictorially represent to understand it better. Now, sorry. Now let's say in the same case, we can have the virtual nodes under the Kubernetes clusters, and it will be taken care from the Azure container instances. So the advantage or the fundamental thing that why we are having it. So you are only paying for it when you are using it. It is probably you can say the serverless offering that we have as a part of extension in the as a part of extension in the Kubernetes. So if we uh, let's say if we talked about only this particular about at this particular step, the Microsoft is not charging you for the master node, but eventually as a customer you are paying for the worker nodes or the agent nodes, even if you are using it or not. Let's say you have spawned the Kubernetes cluster, but you are not doing anything, but still you are charging for you will be charged for the worker nodes or the agent nodes. So when we go one step ahead, in the case of virtual nodes, in the case of AKS, so these will be spawned when there is a need for your application. Let's say you want to increase the number of pods without increasing the underlying infrastructure, or without increasing the you can say you don't want to spawn the VM skill set. You don't want to have the VMs. You want to increase the number of pods or the containers without increasing the underlying infrastructure. So you can go for the AKS virtual nodes. In this, you will only be charged only when you are utilizing that. I hope I'm making sense to all of you. If there are any questions, please ask me. No, I will take it as a no. Moving on. So as we discussed that there are the couple of things that we have discussed: the worker nodes, master nodes, AKS virtual nodes, uh, the pods, the containers, the Docker, and the runtime. So apart from this, obviously, you need to have certain practices that when you're playing around with the Kubernetes, or when you're using the Kubernetes, the Kubernetes alone part will not be enough. So you need to have the monitoring system, you need to have the CI/CD pipeline, you need to have some repository, so that while running your applications, you have the continuous integration and the continuous deployment process, all those things. So please make sure that when you're playing when you're having the Kubernetes clusters, we do have the security in place by applying the NSG, and we also have the other things that we are going to discuss in the upcoming slides from the governance perspective, from the Azure policy perspective. So please make sure that not only the Kubernetes cluster you are leveraging, but also the other services which make your life easy while working with the Kubernetes cluster. Now let's say you have a requirement that uh, uh, you don't want to access the application running on the Kubernetes cluster, or you want a certain users access that particular Kubernetes cluster. So either you have two options. So one is the API server authorizes IP range. You can lock down to the Kubernetes API cluster to a set of trusted endpoints. So basically you are making sure that the request coming from these IP, or the request coming from these users who are only able to access the Kubernetes clusters, the rest all will be denied. Or we can go for the cluster IP that we have discussed in the previous slides. So even eventually that will have only uh, the application will only be accessible under that particular virtual network, not outside that. So again, the same thing, limiting egress traffic. When we so in the previous slide we discussed about the inbound, and now we are discussing about the outbound, the egress, the traffic that is coming out of the Kubernetes cluster. So how you can uh, make sure that you will have the complete you will have the control over the egress applications. So this is also can be made by the NSGs, by the NSGs under that particular subnets. Now, as a I can say network policy, or I can say the Azure policy. So the network policy will will come into picture when you want to have the definite rules or have the more control, how the communication is flowing under the or in the Kubernetes cluster between pod to pod, how the so we are making sure that how we are making the service endpoint publicly accessible, all those things. So basically any communication that is happening in the cluster, that would apply as a Kubernetes network policy, the under the network cluster. Now when we talked about the governance part or the Azure policy for the AKS, let's say we have a team of let's say uh, 3 developers or 3 admin as of now, but going 6 months down the line or going one year down the line, we have increased our team size from 3 to 20 or 3 to 15, anything. Now under that particular thing, you can't go every time to every developer and make sure that these are the rules that you need to follow. Or even if we have those you can say things discussed, but there is always a chance of human error that this is what it is expected, but we have done something different. So to control the you can say the policies or to control the governance at the infrastructure layer, you can define the Azure policies at the AKS level, which will make sure that whatever rules you have defined, every developer will adhere to it. If they are not adhering to the rules that you have defined in the Azure policy, the Azure policy will throw the error to the respective developer. For example, just one example so that everybody can understand. Let's say I define a policy in my I define a rule or a policy in my Azure policy for the AKS cluster, that AKS cluster can only be deployed in the India regions. Apart from the India regions, they will not. The developers or the admins are not allowed to deploy it in the US or in the Europe region. So you have those Azure policies defined for the AKS, and any developer who is trying to spawn up the AKS cluster into the Europe or any other regions will receive an error that this is not allowed. You are only allowed to spawn up the AKS cluster into this particular regions. So this is one such example. But yes, you can control the overall governance and overall factors, that how you want to control the larger broader team adhering to the rules defined at the company level or at the org level. Now, the other thing, the Kubernetes part, the eventually, as we know that it is supporting the Windows and the Linux OS. It can run anywhere. When we say anywhere, in the public cloud, in the private cloud, uh, in the IoT edge, even in the the other offerings that Azure has. For example, the Azure Stack and the Azure Commons. So even this we have discussed, but we will brief it. So the multiple node pools we have discussed. So in the Kubernetes clusters, as pictorial we are showing the different 4 colors. So it's just stating that we have the multiple node pools in which the each configuration of the VM scale set of the VM or the VM under that particular node pool is different from the another one. For example, one configuration might belong to a one particular application. The other configuration might belong to a different application, depending upon your business case, that what is the load and what is the configuration of those machines that you're looking to host that particular application. Other thing, uh, uh, so if everybody or probably some are aware of the Azure functions. So basically, Azure Function is the serverless offering that that uh, uh, that execute on some of the events that happen. So, for example, let's say just to understand it pictorially, uh, there is some message or some data landed into some storage or into some queue. You want the automatic processing of that particular messages or the data. So all those processing can be done by the Azure functions. So we can also deploy the Azure functions by the project called Kida into the Kubernetes, and it will basically help us to have the event based auto scaling. So uh, uh, just to understand it, that uh, on a certain events, you can define the rules that these are the processing things, or these are the business rules that you need to process, and according to that particular rules, you can define the output. But to understand it pictorially, that event-based Kubernetes can be done by the Azure function in the Kubernetes. That project is called KIDA.
Dixit, I have one question. So this Azure functions, we can use it in auto scaling as well, right? Like, because as you said, it will process the messages in a queue, like one by one. The same thing, like in auto scaling also, we required VMs, I mean containers based on the traffic.
So there are two questions to it. So the first question is, can we use Azure function for the auto scaling? Is that
correct? Yeah.
So Azure function has couple of offerings. So I'm right now I'm on, so I'm just describing only the Azure function part, not the Kubernetes in relation. So Azure function had couple of offerings. For example, the dedicated plan, the consumption plan, and the premium plan. Now, in the case of dedicated and the premium plan, you as a developer need to define that auto scaling rules. When we say you need to define that auto scaling rules, for example, you need to define that when my CPU percentage reaches that particular level, scale out my Azure functions. When my memory reaches 60%, scale out my Azure functions. But if you are choosing the consumption tier of the Azure functions, the scaling part, or you can say the auto scaling part, will be taken care by the Microsoft Azure itself. So if you don't want to manage anything from the scaling perspective also, you can choose the consumption tier or the serverless offering of the function app, which is called the consumption tier of the function consumption tier of the function app. Am I clear?
Yeah, thank you. Your first one is consumption tier is a second option. The first one is like
the first one is the dedicated. It is also called dedicated plan or app service plan. And the third tier is the premium tier.
Okay.
But auto scaling from the if you want everything will be handled taken care by the Azure itself, go for the consumption tier of the function app.
Okay, in premium Azure Microsoft Azure will not take care.
It will take care, but you need to define the, for example, the same thing. It has reached 60%, then scale out. It has reached 60% of memory, then scale out. But
we need
in
to
the case,
set the limitations then.
Yes, you not the limitation. You need to set. You need to define the rules. I will say it that way. 60% of CPUs, 70% of memory, the HTTP queue length, 1000 requests. So all those rules you need to define. So when those rules are, or when you can say rules or limits are hit, the auto scaling rules will get triggered and you will get the scaling out feature. But in the case of consumption tier, everything will be abstracted from the developer or the admin and will be taken care by the Azure itself.
Thank you.
These rules can be mentioned in the Kubernetes also, no?
Yes, that is what the KIDA is. That is what I'm saying. The KIDA is. If you want
all these rules will be applicable in Kubernetes cluster range then.
At the pod level.
Yeah, pod level. Yes.
At the pod. Yes, that is all from my side. So these are some of the learning resources that you can have.
You have a question. You have a question in the chat.
Okay.
I've just marked it for you.
Okay. So Chris, that is what I'm saying. If you want to have, first of all, in the Kubernetes cluster, the master node will not be deployed to a subscription or to a resource group. It is deployed as a part of Kubernetes, but as a part of managed offering, you as an admin or you as a developer will not have access to the master node. So that is from the Kubernetes perspective. But if you want to have, still you want to play around, or if you still want to manage the master control, then you need to go for the Azure container service rather than the Kubernetes service. I hope I'm clearing your doubts now.
Dikshit is in hands-on.
Hello.
Lab.
Hi.
Yes, Chris,
hands-on
please
lab?
please go ahead.
This is Christos. Yeah. Well, the answer was not answered actually because I'm focusing the discussion on the worker node because from the perspective of delivering a service for a customer, a web service, let's say, can be enabled by 10 different containers. Those containers normally will be part of the pod of a worker node, and maybe in a single tenant application, they might be under a single subscription. And if we have a second customer, the same pattern can happen, but the worker nodes will be on another subscription if it is single tenant. And then pretty much for every new customer in a single tenant deployment, the worker nodes might need to be deployed under a different subscription, and maybe all of them can be controlled by the master node. Okay, the master node I understand, but the question is if the worker nodes can be deployed under different subscriptions, but still the same master node to be able to control all of them.
Got it. Now, unfortunately, at present, this is not possible because if you see about the FAQs of the Kubernetes cluster, and it is also mentioned in the public documentation as well, that uh, deploying the worker nodes into a different tenant or deploying the worker nodes into a different subscription or moving a Kubernetes cluster from one subscription to another or moving a Kubernetes cluster from one tenant to another is not supported as of now. But yes, work is in progress, but there is no, you can say, a definite timeline which we can give at this particular moment. But as of now, this is not supported.
Thanks.
Thank you.
Dikshit, is there any hands-on lab link?
Exactly. Rashmita, we had given the link of the hands-on lab.
Yeah, you need to check in and you'll get the hands-on labs there. There is
Could
a
you
check-in.
guide me where it is?
It's in the chat. If you go to the chat, I've pasted the check-in link. I'll paste it again if you want. So in the chat, I've just pasted it.
Okay.
Yes. So if you go to that and go to the, do the check-in and go to, make sure that you put in the event ID.
Oh, okay, yeah, got it.
You'll get all the content for this.
Okay, so for Azure, Azure learning purpose also the same kind of event ID will work. Same
Yes,
ID can you
you'll get
utilize
the
because
content for the session which Dikshit has shared. The lab, I think lab details you have shared, right, Dikshit?
Yes.
Yep.
So it has the, you can say, a complete workflow even from the pictorial representation. So step by step details. Step 1, do this. Step 2, do this. So all those details with screenshot is there under the hands-on lab.
oh, thank you. So I'm just definitely Kubernetes. For Kubernetes it will help, but I'm just checking with Azure actually. For Azure, for learning Azure actually.
Same thing. It has both. The lab has both.
Oh, thank you. Okay. I'll check. I just logged into that. Fundamentals of Kubernetes on Microsoft Azure Part 1 it is showing. And the session what we are attending, that is showing that.
You just have to put in the event ID there.
Yeah, I did, but here there is no labs actually. So again, I'm asking.
Let me give me 1 minute.
Yeah, shall I share my screen? Otherwise, because I just given check into access resource for this event. Do I need to give my email ID and?
Yes, you have to give your email ID and all. Then only probably once you do, you'll be able to access the link. If not, let us know. Then probably Dikshit can again send the link.
Okay, I just given my email ID.
Can you share the link all in chat window?
I've just shared it.
Okay.
Any other questions we have?
No, just checking this event ID what you have shared. I click submit and I got one landing page, but there is nothing here. Like it's showing just fundamental Kubernetes, but there is no labs here. That's why I'm.
After you check it?
Yeah.
Just 1 second. Let me see. Oh, there is documentation there.
Documentation.
Once you give your email ID, you'll be able to see a page like thank you for check-in, and you can actually see the links.
I'm also sharing my screen right now, so you can scan the QR code and do the event check-in. This is would be maybe faster.
Vivek, can I ping it in the chat window, the lab thing, or
Yeah.
okay, got it.
We can also post it in the meetup group for everyone. We have a chat there. We can post it there as well so that everybody can get access to it.
Yeah, that would be better, Dikshit, on the meetup page.
Okay. So I will ping you, Rashmita, the hands-on lab link.
Yeah, I will share on the meetup page. But you'll get all, the details there once you do the event check-in. Just scan the QR code, put the event ID, which is 14233, and then followed by email address. And once you put the email address, submit, you'll be able to access all links, plus all related topics, what are sessions which is happening around reactors. It's just not about today's links, also across other reactors. So that's why we were asking to do the event check-in, so you'll get all information put together.
I did that event check-in, but still I'm not getting any. Yeah, okay, event. Okay, I
Are you
got
putting the email address and
yes,
submitting?
I got the thank you for checking in.
Mm-hmm.
Link to event content. Okay, the documents what your workshop is that one.
Yes, there would be link on top. Once you submit, then you can see the link and all. So if you access those links, you'll get all the information there.
Okay, got it. Thank you. The upcoming is there any upcoming session continues to the continuation?
Yes, there would be another second part session to this series, which is on 26th August, same time
Same
at
time.
4:30.
Thank you. Thanks.
Do we have any other questions?
I'm good. Thank you.
Thanks, Gopal.
Then thank you, Dikshit, for the session, and thank you all for joining us today. Please feel free to scan the QR code and do the event check-in. Also, please share your feedback about today's session. It will help us choose our topics that better suit our audiences. Do visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Also, the second part from the same series will be on 26th August, same time at 4:30 p.m. Thank you all once again and enjoy the
That
rest
is
of your
that is
day.
already listed
Thank
on
you.
the calendar.
Yes, it's already there. Probably I'll just share the registration link with you all again.
Okay, thank you.
Thanks, everyone. Thank you.
Thank you. Thank you for joining us.